Hi, I'm Jonathan Harrison and this is my COMP3016 Coursework 1 project. In this video I'll give a quick code walkthrough to explain how the program works. I'll also give a demonstration of compiling and executing the software to show the program running successfully. To start things off, we have the openFile function. This function essentially just opens a file based on the parameter filename. Before we open the file though, we have to check if there's anything in the previous filename storage, and then we can insert the current file, if there's one open, into this storage. We do this here and push it to the back of the previous file storage. To open the file, we first need to check that current file name is not equal to the file name, which means that it would already be open. We then check the return value of sendPage request to see if this vector is greater than 0. If it is equal to 0, that means that it was unsuccessful in opening it, and we would therefore return false. But if it is successful, we clear the current file storage and input our new vector into the file storage. In the case where it isn't a URL, we then go here and simply open a file stream with the file name given, and we then check if that file is open using file.isOpen, which is part of the ifstream library. This will then make sure we output if it's successful or if it's failed, and then we return the response. The next function is called currentFile, and it simply returns a string value based on the currently open file, which can be seen in our file reader class here. After that, we have the line count function, which is also simple and returns the integer value for the amount of lines in the currently opened file. To do this, we open an if stream for the file, and we iterate through the file, counting the lines after each iteration. This is then returned here. After line count, we then have the getLine function. This returns a string value based on the line count given in this parameter, as well as the current file which is open. To do this, we instantiate a if stream based on the current file, as well as an empty string. We then loop until we find the correct line, and each time we loop, we check if the file has ended, and in that case where it has ended, we return an empty string. However, if it keeps looping successfully, we keep appending the string of the next line into string line until we reach the correct line number. In the situation where we do reach the correct line, we then just return this as the string value. From getLine, we then have the getLines function. This essentially works the exact same way, apart from it loops from a start node to the end node and returns a vector of strings. In this, we check if the current file is empty, in which case we just return an empty vector of strings. However, if there is stuff in the file storage at the time, we create a local copy of this with filevec, and we loop from the start to the end. Each time we push this current line into our own vector called lines, and also we check if it's at the end of the file, in which case it is, we just break out of this and then return our lines. In the case where file storage is empty, then we have to create an if stream of the file with the current file name. To do this, we then just check if the file is open and then loop the exact same way, but instead of using lines.pushback with the current index value, we just use the standard getLine and then input this line string into our lines vector. Similar to getLine, we then check if the file is empty or if we are at the end of the file, and then we break out of this function. After all of this, we then just return the lines. In this function, we create a string for the beginning of the node and the end of the node. Using this format, we see that every beginning of a node starts with an arrow and is the value which is given in node type. The ending also has a value and a forward slash, and then the node type again. I've done this here, and after this we then create a vector for the file which is currently open, and we loop through this to see if we have found the beginning of the node or the end of the node. In the case where we do find the beginning of the node, we then iterate through this inNode value to make it equal to 1 from 0, and then this will be activated after each loop to push back the line into our node vector. Once our node vector is full and has been opened and closed, we then go to the remove white spaces function, which essentially just deletes all of the characters before the node, and it does this for the rest of the strings. So for example, here there are 8 spaces here, or 2 tab indentations, and then it will remove these for the entire vector. The inspect for first with the overloaded subnode essentially just does the same thing by calling this function and getting the vector here. It then loops through this vector and inputs the values into the subnode vector. This subnode then has the white spaces removed and is then returned. Next we have the inspect for first attribute function, which takes the parameters for the node and then the attribute. So for example, if the node would be accessor and the attribute would be source, then it would return this value. To do this, we first find this line through this bit of code here, and then we find where the attribute position is and add 2 to it. We add 2 to get rid of this equals and speech mark, and then we add each character of this string into our string until we find the second speech mark, and then this string is returned. We then have the read file function, which just checks for the file name and checks if that file is the currently opened file. This will then be returned to the file storage vector here. Once we check that the current file is equal to the file, we can then see if it is URL1, in which case we'll get the vector by using the send page request function, and then we'll store this in our global value file storage here. In the case where it isn't a URL, we then simply open the file with if streams and loop through it each time we input our line into the file storage vector here. Next we have the close file function. This function takes a string for the file name and creates an if stream for it. It then checks if this file is the currently opened file, in which case I just use the current file closure function and then return the value based on this. If it isn't the currently open file but it is one of the previously opened files, I just simply close it by using file.close, and then I loop through the previous file name storage vector, checking each value to see if it is equal to file name. If it is, then I just erase this value. The close current file function works by closing the current file's if stream and then also changing the current file name based on if there are values in the previous file name's vector. If there are, then it will simply just change the current file name's string to the previous file names.back, which is the last value in this vector. It will then remove this from the vector, and in the case where there is nothing in the previous file storage, it just simply changes current file name to an empty string, showing that there is no file open at the time. The next function is called remove white spaces, and it's used for the inspect for first function. It gets the node and then checks if there are white spaces before the first string of the node. In this case, it then gets the amount of white spaces and then loops through the entire node and removes this certain amount for each line. This will then return the correct node without the indentations before the node. The final function of this program is send page request. This handles the file names which involve URLs, and it uses the boost.asio library. Here we are creating the query by inputting the values from the file name into a vector, which will be used later on in the request and the query. We then create a resolver iterator which will list the endpoints corresponding to the server name, and then we create a socket and we try each of these endpoints until there is a connection made. Once there's a connection made, we form the request and then send it using the socket and the request here. We then read the response status line, and we read it until we find a \r\n, and then we create an iStream for this response and output it here. To check that it's okay, we see if it's equal to 200, and if it is, then that means it's okay, but if it's not, then it will return an error here. Next, we read the header of the URL and input this into a header string here. We then output this header string and we write the body of the file from the URL here.